forest was frozen silent. Snow hung in the air like dust over a grave. German tanks crept through white shadows, engines muffled, their camouflage blending with the endless fog. For 5 days, that fog had been their greatest ally. Allied aircraft were grounded. The skies were blind. Then, without warning, the clouds began to move. A strange light broke through. Thin at first, then widening like a wound in the heavens. Within minutes, the mist dissolved. Shafts of sunlight fell on the snow, glinting off steel helmets and tank turrets. And then came the sound. A deep rolling thunder, not from the earth, but from above. P-47 Thunderbolts and B-26 bombers tore through the new blue sky, diving, strafing, bombing. The German advance froze in disbelief. In command posts across the front, officers stared at the weather maps. The impossible had happened. The fog had vanished. Not naturally, not by chance. To them, it felt as if America had done the unthinkable. It had turned the weather itself into a weapon. Long before the first bomb fell on Berlin, every general in Europe knew one unshakable truth. Weather wins wars. It grounded bombers, drowned invasions, froze tanks, and blinded scouts. But in 1939, only one nation truly understood that mastering the sky meant mastering the battlefield. Germany entered the war with the world's most advanced engineers, but its meteorology remained archaic, fragmented, decentralized, and rooted in peacetime observation rather than wartime prediction. The Reich's scientists could build rockets that reached the edge of space, yet they struggled to forecast a storm. Their data came from civilian weather bureaus, ships, and a few Arctic outposts. Too few, too scattered, too vulnerable. The United States, by contrast, had begun turning weather into infrastructure. Even before Pearl Harbor, the U.S. Army Signal Corps had founded a vast meteorological service, a network of weather stations stretching from the Caribbean to Alaska, staffed by physicists, mathematicians, and radio operators. What began as a civilian curiosity became a military system of astonishing precision. Every forecast was data, every wind reading a weapon. By 1941, American meteorologists were not simply studying clouds, they were quantifying them. Using new electronic barometers, radar experiments, and balloon soundings, they charted the invisible oceans of air that governed flight. At the Massachusetts Institute of Technology, scientists developed the first models to predict atmospheric fronts days in advance. The Weather Bureau's daily bulletins became classified military material. While Germany relied on intuition and experience, America built prediction into its war machine. When the U.S. entered the war after Pearl Harbor, this invisible infrastructure mobilized overnight. Meteorological squadrons were deployed alongside combat units. In North Africa, they forecast sandstorms that shaped entire campaigns. In the Pacific, they guided fleets through typhoons. And in Europe, they prepared for something even greater. A global war fought on two hemispheres, where every bullet, bomb, and ship would depend on the next hour's sky. The key lay in communication. The U.S. established the Army Air Force's Weather Wing, an organization whose sole mission was to feed atmospheric intelligence into operations planning. From Greenland to Guam, hundreds of outposts transmitted coded data through shortwave radio. Temperature, humidity, and pressure readings were plotted into vast maps that stretched across the Atlantic. No other nation possessed such reach. German meteorologists knew this disadvantage and tried to compensate. In 1941, the Kriegsmarine launched daring Arctic expeditions to plant automated weather stations on the ice. Small metal huts, powered by wind turbines, sending Morse signals back to Norway. Many never transmitted. Others were captured by Allied patrols. The Atlantic, the planet's greatest weather engine, belonged to America's network. Meanwhile, a quiet scientific revolution unfolded behind laboratory doors. In Washington, the U.S. Naval Research Laboratory began experimenting with early radio radar, not only to detect aircraft, but to see storms. The oscillating echoes from rain and clouds created ghostly shapes on cathode ray screens, the birth of meteorological radar. What had been invisible was now observable. It was as if the Allies had opened a new dimension of warfare, the ability to see into the sky itself. To military strategists, weather was no longer background. It was terrain, shifting, exploitable, conquerable, and America was learning to navigate it with mathematics instead of instinct. By 1943, the difference was stark. When Allied bombers left English airfields for daylight raids over Germany, each formation carried meteorological officers whose charts and reports dictated the routes. When the Luftwaffe retaliated, they relied on outdated field forecasts and scattered observations. The German High Command still viewed weather as fate. The Americans treated it as engineering. Yet the true test of this invisible weapon would come the following year, when all of Europe waited for a storm to pass, or to arrive. In 1944, a single forecast would decide the largest amphibious invasion in history. That decision, to land on the beaches of Normandy, would prove that controlling information about the sky was as decisive as any weapon built beneath it, and for the scientists watching from Berlin, it would be the first time they realized what they were truly facing. A nation that didn't just fight in the weather, it fought with it. In early 1944, the world's most secret battlefield was not fought on land or sea. It unfolded across the upper atmosphere. Jet streams, oceanic pressure ridges, and air currents became strategic assets. The ability to predict them meant the difference between victory and annihilation. For the Allied command, every operation depended on this unseen front. The invasion of North Africa had been delayed by sandstorms. The Sicilian campaign hinged on a 3-day window of calm seas. But nothing would test meteorological warfare like Operation Overlord, D-Day. The Allied invasion of Normandy required absolute precision. Tides, winds, cloud cover, moonlight, and wave height all had to align. A single miscalculation could scatter landing craft, ground aircraft, and drown thousands before they reached the shore. The Germans, confident in their own forecasts, expected no invasion before mid-June. Their meteorologists predicted weeks of violent storms sweeping the Channel. They were almost right. On June 4, 1944, a raging Atlantic front approached England. Waves crashed at double height, winds howled across southern airfields, and the sea boiled under lightning. The German command concluded no landing could occur for days. Rommel himself left for Berlin, believing the weather had bought them time. But inside a small hut at the Royal Air Force Station at Dunstable, American and British meteorologists saw something the Germans could not. Using transatlantic weather data from Greenland, Iceland, and remote ocean stations, they noticed a brief atmospheric shift, a narrow break in the storm pattern, predicted to last less than 36 hours. It was the eye of an invisible storm moving eastward. If timed perfectly, the Allies could use it to strike before the next front closed in. Group Captain James Stagg, the Scottish chief meteorologist, presented his forecast to General Eisenhower on June 5th at 400 hours. "If we go tomorrow," he said quietly, "we will have one day of fair weather." Eisenhower looked at the maps, pressure systems swirling like galaxies, and made the decision that would change history. The invasion would proceed on June 6th. At dawn, the storm calmed. Clouds parted just enough for the first paratroopers to jump. The sea, still restless, flattened under steady winds. The German radar network, expecting gale conditions, remained on partial alert. When the first wave of landing craft appeared off Normandy, the defenders were still convinced the channel was impassable. That forecast, that single, fragile thread of meteorological insight had turned nature itself into an ally. It was not luck. It was data. And it was something Germany could not match. The reason lay in the structure of wartime science. The Allied meteorological network was centralized, mathematical, and industrialized. Thousands of observers feeding numbers into coordinated systems. Germany's, by contrast, was fragmented. The Luftwaffe, Kriegsmarine, and Army maintained separate forecasting units, each jealously guarding their data. The result was redundancy without accuracy, ambition without integration. Even more critically, the Allies had extended their reach across the Arctic. In 1943, the U.S. Coast Guard, alongside Canadian forces, established a chain of weather outposts in Greenland and Newfoundland. These northern sentinels provided the earliest warnings of Atlantic pressure fronts, hours, sometimes days, before they reached Europe. German U-boats, trying to deploy their own stations on the ice, were hunted relentlessly. Of the few that succeeded, most were lost within months. The Reich had entered the weather war too late. By 1944, America's weather intelligence had fused with its war machine. Balloon soundings, radar echo data, and aircraft reconnaissance formed the backbone of what military planners called Meteorological Operations Command. Every bombing raid, every convoy, every amphibious assault was timed against atmospheric probability. The sky had become part of logistics. In contrast, German scientists worked in isolation, improvising forecasts with incomplete data. Even Werner Heisenberg, the famed physicist, reportedly complained to colleagues that our generals expect certainty from clouds. His remark captured a truth that haunted the Reich's scientific establishment. The Americans weren't simply observing weather. They were commanding it through numbers. The D-Day forecast, when studied after the war, stunned German meteorologists. They could not understand how the Allies had detected the small gap in the Atlantic storm, an event their instruments never recorded. The answer was simple yet profound: coverage. America's meteorological net was global. Germany's was continental. From that moment, the lesson was clear. The future of warfare would not be won by bigger guns or faster planes, but by superior information. For the Germans, it was a realization that came too late. For the Americans, it was the beginning of something greater. The idea that even nature could be calculated, predicted, and, one day, controlled. And as 1944 turned to 1945, the weather itself would decide the course of one final desperate German gamble. When fog, snow, and silence descended over the Ardennes, that battle would show the world not just how America read the skies, but how it learned to shape them. By late 1944, the sky itself had become a battlefield. Every drop of rain, every gust of wind, every rolling cloud now had meaning. To some, weather was a natural hazard. To America, it was an instrument of command. To German scientists, the American mastery of atmospheric prediction appeared almost supernatural. But inside American laboratories, it was the result of one of the most disciplined scientific mobilizations in history. The U.S. Army Air Forces had quietly transformed meteorology from a civilian curiosity into an exact science of warfare. At the University of Chicago, a young generation of physicists worked under the mentorship of Carl Gustav Rossby, the Swedish-born pioneer who defined jet streams. His equations, once obscure academic work, became vital for high-altitude flight planning. By 1944, Rossby's theories helped bomber formations exploit tailwinds over Europe. Cutting fuel consumption and increasing range. Simultaneously, radar technology revealed the physical structure of weather. Engineers at the Massachusetts Institute of Technology and the Naval Research Laboratory discovered that radar waves, initially designed to detect aircraft, bounced differently from rain or snow. What they saw were ghostly green swirls, moving storms, visible for the first time in real time. With this knowledge, America had achieved something no military had before: the ability to visualize the invisible. And that was power. German engineers at Peenemünde, accustomed to mathematical precision, were astonished when Allied air raids arrived only during clear weather windows. They called it Der Wetterkrieg, the weather war. It was not exaggeration. The Americans were fighting with equations as much as with ammunition. Every forecast the U.S. generated fed into operational maps across the European theater. The timing of each bombing run, the altitude of each squadron, even the synchronization of artillery fire depended on atmospheric predictions measured in fractions of a millibar. Precision had left the barrel of the gun and entered the air itself. On the ground, this science translated into tactics. In December 1944, when Hitler launched Unternehmen Wacht am Rhein, the Ardennes offensive, he counted on fog and snow to cripple Allied air support. The first week went exactly as he hoped. Planes were grounded. Supply lines froze. German panzers advanced under the white curtain of nature's camouflage. But what the Wehrmacht didn't realize was that America's meteorologists were already plotting the return of the sun. Using high-altitude data from Greenland and Iceland, they detected a slow-moving ridge of pressure creeping eastward. When that ridge reached Belgium, it would sweep the fog away. At 09:30 hours on December 23rd, it happened. The clouds broke. Allied aircraft roared into the sky. P-47s, P-51s, and B-26 ripped through the mist, striking columns trapped on narrow forest roads. It was not coincidence. It was calculation. American weather officers had predicted the exact hour the skies would clear and prepared the strike in advance. In a sense, the sun itself had become a weapon. The weather turned the tide more decisively than any single division. Captured German reports later confirmed it. Enemy aircraft appeared the moment visibility returned, one officer wrote bitterly. It was as if they commanded the sky. To Germany's high command, this was incomprehensible. Their doctrine relied on momentum and surprise, not environmental prediction. To them, war was human. To America, it was systematic. And in that system, even clouds could be conquered. The effect on morale was immense. To Allied troops, those sudden breaks of sunlight during the Battle of the Bulge became symbols of divine intervention. The miracle of the weather. Chaplains preached that the heavens had opened for democracy. Pilots believed God himself cleared the skies. Only the meteorologists knew the truth. The miracle had been calculated. To German soldiers, it was something else entirely. A spiritual collapse. For years, propaganda had portrayed the Americans as dependent on machines. Yet here was proof that even nature seemed to obey them. One captured German lieutenant described it as fighting against the elements themselves. To men raised on Prussian faith in fate, it was demoralizing beyond measure. The irony was cruel. The nation that once prided itself on engineering genius was now being out-engineered in the one domain it had never considered conquerable: the sky. Even Hitler noticed. In his bunker briefings, he raged at his staff meteorologists, accusing them of betrayal. They were helpless. The Reich had no satellite data, no global network, no Arctic telemetry. America did. What Germany called Gottes Wille, God's will, America called a weather report. That difference defined not only the war's final months, but the philosophy of 20th century warfare itself. The United States had proven that with enough data, even the heavens could be tamed, and in the process, it exposed a painful truth for its enemies: that faith and courage could not compete with mathematics and machinery. In the final winter of the war, Germany still possessed brilliant minds. Men who had split the atom, built supersonic aircraft, and guided rockets toward London. Yet, they could not predict tomorrow's sky. Meteorology inside the Reich was fragmented chaos. The Reichswetterdienst, State Weather Service, operated separately from the Luftwaffe and Kriegsmarine, each maintaining its own forecasts. None shared information efficiently, and all suffered from a single fatal weakness: isolation. Allied bombings had severed communication lines. Weather balloons launched from occupied France or Norway often vanished without report. U-boats that gathered atmospheric readings in the North Atlantic were hunted down before they could transmit. By 1944, German weather data was days old, stale information in a war fought by the hour. The Allies, meanwhile, were running what one German scientist later called the first planetary experiment in meteorology. With observation points stretching from the Arctic to the equator, the United States had effectively surrounded the Reich in an invisible cage of knowledge. Every frontline storm was measured, mapped, and transmitted. For German officers reviewing post-war reports, the conclusion was humiliating. They had assumed the Americans' power came from industry, numbers, and oil. Now they saw it came from systems. The same nation that could build a bomber every 30 minutes had also built a scientific machine that forecasted the weather of the entire Northern Hemisphere. Dr. Erich Etienne, a leading German meteorologist captured in 1945, summed it simply: "We were fighting men who could see the sky as an equation." That equation had destroyed the notion of fate, and it had proven that intellect, not instinct, was the decisive weapon of modern war. The war's most decisive minds rarely carried rifles. They carried barometers. In icy outposts across Greenland, Iceland, and the Aleutians, American meteorologists endured conditions as harsh as any battlefield. Their huts, wooden boxes anchored by cables against hurricane-force winds, were isolated for months. Their only task: measure, record, and transmit. A single misread pressure drop could alter an entire invasion plan. A single transmission delay could cost thousands of lives. Many of these men were barely out of college: physicists, mathematicians, and radio amateurs drafted into the Weather Corps. They learned to navigate storms, climb frozen masts, and operate instruments while frostbitten. They were the unseen soldiers of the atmosphere. In the Pacific, others flew weather reconnaissance missions, unarmed B-24s slicing through typhoons to record barometric data. They called themselves storm chasers, long before the term existed. Theirs was a silent mathematical courage, to fly into chaos so that others could avoid it. Few would ever be decorated. Fewer still would be remembered. Yet their readings, lines of numbers on narrow telegraph tapes, guided fleets, bombers, and armies. When Eisenhower later said, "We owe the success of Overlord to the weathermen," he was not exaggerating. These anonymous observers had turned survival into science. In an age of heroes, they were the unseen ones, the men who fought with thermometers instead of guns. But with mastery came unease. The more control mankind gained over nature, the more that control began to resemble power. By 1945, American scientists had proven they could use data to manipulate battlefields. In laboratories, early experiments with dry ice and silver iodide hinted at something extraordinary: that clouds could be induced to rain or dissipate under controlled conditions. It was only theory then, but it raised a question that haunted even military planners. If we can command the weather, what else can we command? In the post-war years, that question became prophecy. The experiments begun under wartime urgency evolved into Project Cirrus and later Project Storm Fury, the first organized attempts to alter weather deliberately. And it all traced back to those wartime systems: the radar screens, the global telemetry, the equations born from conflict. What began as defense had become dominion. Yet during the war itself, moral reflection was scarce. For Allied commanders, each forecast was a weapon of mercy as much as destruction. saving lives by choosing when to fight. For German officers facing annihilation under clear skies, it felt like divine punishment. One captured colonel reportedly told his interrogators, "You have taken the heavens from God and given them to engineers." The line was poetic, but the meaning was clear. The Americans had not only changed the outcome of battles, they had changed humanity's relationship with the sky. The weather, once the ultimate symbol of chance, was now a function of will. The storm no longer decided war. Man did, and in that realization lay the final, silent victory, one that extended beyond 1945, into every age where data replaced destiny. By the end of the war, the Americans' quiet conquest of the atmosphere was undeniable, but their greatest demonstration was still to come. A single campaign where weather, technology, and strategy fused into one unstoppable force, the Battle of the Bulge. December 16, 1944, the Ardennes Forest. The last German offensive of the war began not with a roar, but with silence. Snow fell in thick, muffling sheets. Visibility dropped to almost nothing. Allied aircraft were grounded. Communications crackled weakly through static. For once, the battlefield belonged entirely to the enemy. Adolf Hitler had built his final gamble on this curtain of weather. The offensive, codenamed Wacht am Rhein, depended on fog. He believed that if the skies remained closed, Germany could strike through Belgium, divide the Allied front, and capture Antwerp. It was an audacious plan, one that ignored logistics and reason, but not the weather. The Führer had convinced himself that divine clouds would blind the Americans long enough to change history. And for a time, he was right. For 5 days, fog choked the Ardennes. Allied reconnaissance planes could not fly. Artillery spotting was blind. American convoys struggled through snow-choked roads. Tanks iced over in motionless lines. German armor, tigers and panthers, moved like ghosts through white forests. Allied commanders could barely chart their own positions, let alone the enemy's. The fog was the perfect weapon. Impartial, silent, merciless. But in a bunker near Versailles, American meteorologists were already watching it unravel. The U.S. Army Air Force's 21st Weather Squadron, operating under the 9th Air Force, had been monitoring a ridge of high pressure moving eastward across the Atlantic. Their readings from Greenland and Iceland showed an approaching shift, subtle but undeniable. Within days, the cold blanket smothering Belgium would lift. It was a race between time and temperature. At the front, soldiers endured frostbite and isolation. Units were cut off. Fuel was scarce. For the Germans, initial success felt intoxicating. They ambushed columns, seized villages, and watched American morale falter. The bulge widened, and Hitler exulted. "Our weather is fighting for us." But in reality, it was slipping away. By December 22nd, American forecasters saw the change coming faster than expected. Their graphs showed a sudden drop in humidity, followed by an upward swing in barometric pressure. If they were right, the fog would vanish within 48 hours, opening the sky to the most powerful air armada in human history. The Allied commanders waited. Then, on the morning of December 23rd, the sky cracked open. The clouds broke like a curtain torn from the heavens. A pale sun spilled over the snowbound fields of Belgium, and with it came sound, the deep, rolling thunder of engines. Wave after wave of Allied aircraft filled the sky. Thunderbolts, Mustangs, Typhoons, Marauders, Liberators. Thousands of planes rose from British and French airfields in synchronized precision. Within hours, they struck the roads and forests where German armor had been hidden for days. Panzers burned. Columns scattered. The very fog that had once concealed them now became a death trap as sunlight reflected off snow and smoke. For American troops on the ground, the sudden roar of aircraft was salvation. For the Germans, it was the sound of fate reversing. One infantryman of the 2nd Panzer Division later wrote, "The sky opened, and with it, hell came down." The effect was devastating. Allied bombers destroyed convoys, rail lines, and bridges in hours. German fuel reserves, already critical, evaporated in smoke. Luftwaffe support, grounded by lack of fuel and frozen runways, could not intervene. What had begun as a brilliant strike dissolved into chaos under the glare of a clear sky. It was not chance. It was the culmination of an invisible operation, a calculated understanding of the atmosphere, executed with military precision. In the following days, Allied dominance grew absolute. American meteorologists continued to chart the advancing ridge, allowing round-the-clock bombardment. Weather stations updated targets hourly. Pilots could now fly predictable routes through stabilized air currents. By Christmas Eve, German troops who had advanced under clouds were now retreating under sunlight. The very weapon that had enabled their surprise had turned against them. Behind the front, captured German officers stared at the weather maps confiscated from American command posts. They could hardly comprehend the scale. Data flowing from across continents, synchronized across divisions, perfectly integrated into operational planning. Their own meteorological reports, handwritten and delayed, looked primitive by comparison, and yet the psychological blow was even deeper. What the Germans had called Zufall, chance, the Americans had turned into design. The atmosphere itself seemed to answer to them. In Berlin, reports of the Ardennes disaster reached the high command. General Jodl blamed the weather's betrayal. Hitler refused to believe it, accusing his forecasters of incompetence. But among the scientists of the Reichswetterdienst, the truth was clear. They had been outnumbered, outmeasured, and outthought. The Americans had waged a new kind of war. One fought not only with weapons, but with wavelengths and air currents. As one captured meteorologist later told his Allied interrogator, "We fought men who read the sky like scripture." By the end of December, the fog was gone. So was Germany's last hope of reversing the war. But the Battle of the Bulge had revealed something far more profound than tactical failure. It showed that nature itself, wind, sun, pressure, and temperature, could now be orchestrated with human precision. It was the dawn of a new philosophy of warfare, one that saw the world not as chaos, but as code. And as the Allies pushed eastward through a frozen Europe, that code continued to unfold, guiding armies, bombers, and ships alike. Because America had not merely learned to predict the weather, it had learned how to command it. While Europe burned beneath clear skies, another theater of war was testing the same unseen power: the Pacific. Here, weather was not merely a tactical factor. It was life and death. Typhoons, monsoon rains, and vast distances made meteorology the spine of every campaign. The United States, having perfected its forecasting system in Europe, now extended it across half the planet. From Hawaii to Guam, from the Philippines to the Aleutians, networks of weather ships, radar stations, and reconnaissance aircraft tracked the shifting heartbeat of the Pacific. These readings were fed into enormous plotting boards at the Fleet Weather Central in Pearl Harbor. For the first time in history, a military command could watch the movement of entire weather systems in near real time. And with that vision came strategy. On the night of March 9, 1945, Tokyo burned. The city's destruction, the deadliest air raid in human history, was planned not only by pilots, but by meteorologists. The U.S. Army Air Forces had determined that the jet stream over Japan would produce powerful surface winds from the west that night. Combined with unusually low humidity, it created the perfect conditions for firestorm propagation. The raid's planners, led by Curtis LeMay, timed the departure of 334 B-29 bombers to meet this atmospheric corridor. When the first incendiaries fell, the results exceeded calculation. The dry wind, predicted by weather models, whipped flames into cyclones. Temperature differentials created vortices that tore entire blocks from their foundations. Within hours, Tokyo's wooden districts became a furnace. 100,000 dead, 16 square miles of city erased. It was the first demonstration that atmospheric understanding could magnify destruction as efficiently as any bomb. Even German observers, following the reports, were aghast. "They plan their weather," one captured Luftwaffe officer remarked later, "as we plan artillery." By midsummer 1945, meteorology had become central to operations of unimaginable consequence. The Manhattan Project's scientists and the Army Air Forces coordinated through the 509th Composite Group on Tinian Island. Their task was not only technical, it was environmental. The success of an atomic strike depended on visibility, wind direction, and the vertical movement of air. For weeks, weather reconnaissance aircraft flew over Japan at dawn, measuring humidity layers and wind shear. On August 6, 1945, the readings came back perfect. Broken clouds over Hiroshima, clear conditions at 30,000 feet. Enola Gay was ordered to proceed. At 08:15 local time, under a flawless blue sky, the first atomic bomb fell. Observers later noted how the air itself seemed unnaturally still. No turbulence, no crosswind, as if the atmosphere held its breath. 3 days later, the second mission faced storms over Kyushu. For hours, crews debated whether to strike Nagasaki or Kokura. Finally, a last-minute report from a weather plane, relayed through cloud observation radar, confirmed a narrow visual gap. The B-29 Bockscar turned south. The bomb dropped through that brief clearing. In a war defined by uncertainty, even apocalypse required a weather window. When Allied investigators later uncovered German intelligence files, they found dozens of memoranda detailing American meteorological capabilities. To the German High Command, it was both revelation and humiliation. One report from the Heereswaffenamt, Army Weapons Office, concluded bluntly, "The enemy conducts his operations according to the sky's rhythm. We react after he has already moved." Another, written in March 1945, warned that American air power no longer depends on favorable conditions. It creates them. For German scientists, these admissions were unbearable. They had believed themselves the intellectual elite of Europe, heirs of Humboldt and Gauss. Yet they had underestimated a nation they dismissed as industrial and unrefined. Now, in laboratories from Peenemünde to Berlin, they studied captured Allied equipment in disbelief. Radio sonde balloons that reached the stratosphere, radar sets tuned to detect rainfall, computer-aided forecast charts. The Americans had built an empire of measurement. The realization was philosophical as much as technical. In Prussian doctrine, obedience and discipline created order. In American doctrine, engineering generated it. One system was human, the other systemic. General Alfred Jodl, in a final briefing at Hitler's bunker, summarized it with rare clarity. "They have reached the point where even the act of firing, or flying, is no longer human. It is electrical." He was speaking not only of artillery, but of the entire apparatus of mechanized intelligence that had surrounded Germany by 1945. Electricity powered their communication, their radar, their bombers, and, in a sense, their will. When surrender came in May, Allied intelligence officers debriefed captured meteorologists. Many described their astonishment at the scale of the American system. One German scientist compared it to fighting against the atmosphere itself. Another said bitterly, "We had barometers. They had the planet." The collapse of the Reich was visible not only in ruins, but in realization. The future of war had moved beyond men and machines. It now flowed through wires, circuits, and invisible currents. From Aachen to Hiroshima, every major Allied victory had been timed, not by luck, but by atmospheric mastery. The Americans had not only conquered the land, sea, and air. They had conquered the conditions in which war existed, and to the vanquished. Scientists of Germany, that was the most terrifying weapon of all. By the time peace returned, the age of industrial warfare had ended. In its place emerged something new, a world where science itself could direct destruction with the precision of a clock. But even as the world celebrated victory, a deeper question remained. Had mankind gained control over nature, or merely replaced nature's chaos with its own? That question would shape the aftermath, a new era where meteorology would evolve from prediction to manipulation. May 1945, Germany surrenders. The world exhaled, but the wind carried new questions. In the ruins of Europe, Allied technical teams moved swiftly through abandoned laboratories and weather stations. Their orders were not to seize weapons, but data. Every fragment of meteorological intelligence, barometric logs, isobar charts, experimental radiosonde designs, was catalogued and shipped to London or Washington. To the ordinary soldier, these seemed trivial spoils. To the scientists, they were priceless. For 6 years, war had accelerated atmospheric science by decades. What began as a support tool, predicting rain for bombers or fog for landings, had evolved into a weaponized system of information control. The Allies now understood that whoever controlled the flow of data controlled the tempo of war itself. In August 1945, as Japan lay in ashes, the U.S. Joint Meteorological Committee issued its first post-war directive. Weather is now a global instrument of statecraft. It was not rhetoric. The networks that had once fed D-Day and the Battle of the Bulge became permanent. The Air Force transformed its wartime weather wing into the Air Weather Service, maintaining over 400 stations across the world. Ships that once carried bombs now released balloons. Aircraft that once dropped mines now carried sensors. Every hour, coded transmissions pulsed through the ether. Temperature, pressure, wind velocity, forming the first global meteorological grid. For the first time in history, humanity was measuring itself against the sky continuously. Ironically, the very nation that had pioneered modern meteorology in the 19th century became its post-war classroom. Under Operation Paperclip, captured German scientists were brought to the United States. Among them were experts from the Reichswetterdienst and the Luftwaffe's Upper Atmosphere Division. They had once plotted cloud cover for bombing raids. Now they taught at American bases how to interpret jet streams and thermal layers. Their records, precise, methodical, and written in the cautious script of bureaucrats, revealed how close Germany had come to discovering the atmospheric patterns the Allies had mastered. But where Germany's research remained academic, America's had become industrial. The difference lay in infrastructure. The United States had turned science into logistics, a machine capable of applying knowledge at scale. By 1946, U.S. naval fleets carried portable weather labs. Army divisions moved with mobile forecasting trucks. Even civilian air routes were coordinated through military meteorological networks. The American sky had become a circuit. For the captured German meteorologists, this realization was humbling. Their discipline, once devoted to predicting rain for farmers, was now a pillar of warfare, diplomacy, and navigation. Many adapted, contributing to post-war programs like Project Cirrus, the first U.S. attempt to deliberately alter weather through cloud seeding. As one former Luftwaffe scientist confessed in 1947, "We spent the war fearing their machines. we should have feared their mathematics. Across the new divide of the Iron Curtain, the Soviet Union watched closely. Stalin's generals studied Allied weather systems with both admiration and alarm. Within months of Germany's fall, Soviet engineers began constructing a vast meteorological network of their own, stretching from Murmansk to Vladivostok. Soviet intelligence even attempted to recruit captured German weathermen before the Americans could. By 1948, both superpowers had recognized the same truth. The next war, if it came, would begin not with bombs, but with data. And so the Cold War inherited the skies. Every radar pulse, every atmospheric sounding became part of a silent duel. Balloon launches doubled as espionage. Weather planes became reconnaissance tools. The meteorological laboratories that once predicted D-Day now fed information to missile command centers. Forecasting had become surveillance. Atmospheric measurement had become geopolitics. But for many veterans of the Weather Corps, this transformation carried unease. They remembered the war's moral clarity, predicting the storm for Normandy, clearing the fog for bombers over the Rhine, and wondered whether peace had twisted their purpose. In the late 1940s, American newspapers hailed the conquest of weather. Yet inside the Pentagon, the phrasing was darker. Memoranda referred to strategic control of atmospheric conditions. Some experiments tested whether seeded clouds could cause rain over enemy supply lines or dry fields during harvests. The line between prediction and manipulation blurred. Dr. Irving Langmuir, one of America's leading physicists, warned in 1948, "We have learned to touch the breath of the world. We must decide whether to heal with it or to harm." Those words echoed through the new scientific generation. Men and women who had seen how data could command armies, but also how easily it could command conscience. By 1950, the United States and the Soviet Union were not only racing for atomic supremacy, they were racing to command the weather. And beneath that race lay the same question that haunted the closing years of the war. Had man become the master of the elements, or merely their prisoner? From here, a new era would rise, one where the lessons of atmospheric warfare became the foundation for the digital age. But before that future unfolded, the human cost and moral reckoning of weather weaponization had to be faced. Cities rose from ashes, bridges were rebuilt, but the skies, those remained under watch. Every day, across continents, the silent rhythm of the new weather networks pulsed on. Balloons ascended from Alaska, the Azores, and Okinawa. Transmissions flickered through shortwave radio, linking meteorological stations from Washington to Berlin, from Guam to London. The war's data infrastructure had outlived the war itself. It had become the nervous system of a planet, learning to monitor its own heartbeat. In Washington, generals and scientists gathered under a new directive, Project Cirrus, the first attempt to deliberately influence the weather. It was born from victory and anxiety both, the belief that if man could predict the sky, he might also command it. In 1947, a U.S. Army Air Force's B-17 dropped dry ice into a hurricane forming off the coast of Georgia. For hours, the storm's trajectory shifted sharply before regaining strength. The newspapers called it the day the Air Force moved a storm. Though the results were uncertain, the symbolism was unmistakable. The science that had guided bombers over Germany was now reaching for the clouds themselves. Throughout the late 1940s, laboratories once devoted to wartime prediction became hubs of experimentation. At Wright Field, Langmuir's team studied cloud condensation and ionization. In New Mexico, physicists examined atmospheric electricity. The same principles that once guided radar, now used to understand lightning. And in California, engineers at Caltech and the Navy's China Lake tested aerial dispersal systems for seeding experiments. The language of war remained. Reports described deploying agents, targeting cloud masses, and achieving saturation. The meteorological lexicon had fused with military precision. Meanwhile, the Soviet Union raced to match these developments. Stalin ordered the creation of the Institute for Atmospheric Physics in Moscow, a direct parallel to America's own research centers. Soviet scientists, many of them former German researchers, experimented with silver iodide dispersion and storm formation. They understood the strategic implication. Whoever mastered weather could dictate logistics, agriculture, even morale. The idea was intoxicating and dangerous. By the early 1950s, weather control had become both a scientific dream and a military secret. The U.S. Navy's Project Skyfire and Project Storm Fury sought to disperse hurricanes, while intelligence agencies quietly explored environmental modification as a tool of covert warfare. In classified memos, planners described how rainfall could bog down enemy roads, how drought could weaken harvests, how artificial fog could hide airfields. The same impulse that had cleared the skies over the Ardennes was now being weaponized in peacetime. To the public, these experiments were framed as humanitarian, efforts to protect cities from storms or bring rain to farmers. But behind closed doors, the memory of the war lingered. The Battle of the Bulge had shown what happened when weather turned into a battlefield variable. No strategist wanted to be caught unprepared again. Among scientists, unease grew. Dr. Merle Tuve, who had once developed proximity fuses for Allied bombs, spoke in 1951 at a symposium in Washington. "We once used magnetism and air pressure to measure the enemy. Now we use them to measure ourselves. Let us not forget what that power can do." Tuve's warning reflected a deeper anxiety, that the tools of control forged in war were slowly shaping the peace itself. Electricity, once used to synchronize artillery, now flowed through communication grids and weather stations, linking humanity in invisible currents of dependence. For some, it was progress. For others, it was a quiet conquest, not of nations, but of nature. Meanwhile, in occupied Germany, a quiet transformation was underway. Former Luftwaffe meteorologists were integrated into the new Deutscher Wetterdienst, founded in 1952 under Allied supervision. They helped rebuild Europe's civilian weather systems using American equipment and methodology. Yet, behind this reconstruction lay a ghost of defeat, a silent understanding that the very science they once weaponized had outgrown them. One German scientist, Dr. Hans Neuberger, reflected in a 1953 interview, "We entered the war believing nature could be tamed by discipline. The Americans tamed it with understanding. That difference became the moral dividing line of modern science. Knowledge could no longer be separated from power, and power could no longer be contained within borders." By the mid-1950s, the world's major powers had built an unbroken chain of atmospheric surveillance, the precursor to satellites, to missile tracking, to climate science itself. The sky had become a shared battlefield of data. In 1958, the U.S. launched its first meteorological satellite, Vanguard 2, designed to measure cloud cover from orbit. Its roots traced directly back to the wartime radar balloons and weather ships that once guided bombers over Europe. The same circuits that had once decided life and death now circled the Earth in silence. The age of global observation had begun. The weapon that started as a theory, turning weather into a force multiplier, had evolved into something larger, the foundation of the information age. And through it all, one truth endured. The war had not ended in 1945. It had simply changed form. The battlefield had moved from the mud of Europe to the invisible frontiers of the sky. From these ashes and ambitions, a new philosophy would emerge, one that asked not how to destroy, but how to understand. And yet, the shadow of that wartime revelation would never fully fade. The war that began with steel and smoke ended with silence. A silence filled with circuits, signals, and the hum of machines reading the sky. By 1945, humanity had crossed an invisible threshold. In mastering the weather, man had mastered the unseen. The atmosphere, once divine and untouchable, had become measurable, predictable, and, in moments, obedient. Yet with that mastery came a question that no victory parade could answer. What happens when control replaces understanding? The German scientists who once laughed at America's unrefined engineering left the war with a kind of awe. They had witnessed a civilization capable not merely of invention, but of integration. A power that bound meteorology, mathematics, and machinery into one living system. What they had built with discipline, America had built with connection. In that difference lay the future of the modern world. Every radar station, every forecast network, every satellite that now orbits the Earth carries the echo of that wartime revolution. The idea that the environment could be charted, modeled, and used as a tool. It was born in the frozen skies over Belgium, when fog lifted and sunlight became a weapon. But history's irony endures. The same science that once guided bombers to targets now predicts hurricanes and saves cities. The same instruments that once measured destruction now measure climate, temperature, and change. War gave humanity a mirror, and in it we saw both our brilliance and our danger. For in learning to shape the weather, man discovered his greatest illusion, that he could shape consequence as easily as clouds. The air remains obedient only to its own laws, and though we can read it, seed it, or momentarily bend it, the wind still belongs to the world. Perhaps that is the final lesson of the age that turned weather into a weapon. That every attempt to command nature ends where it began. Under the same sky, shared by all and beyond the reach of any flag.